Well, there it is, Earth. And seeing as how this is Earth science, I guess it's about time that we start talking about and learning about the Earth. And the first thing that I would like to do here is I'd like to ask a question. What is it made out of? Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. So to answer that question, I'd like to start off with this. You've seen this before, maybe not this version of it, but this is the periodic table of the elements. And so I'd like to take a step back, actually, and talk about what the universe is made out of, what the stuff in the universe is made out of. And you may remember studying this periodic table, and basically this is a list of all the stuff that the universe is made out of. These are the elements, these are the basic building blocks of all the things in the universe and what all those things are made out of. In the same way that you can build a house or a car out of Lego blocks, and you have lots of different types of Lego blocks. You have the little square ones and the regular little rectangle ones, and you have the little flat pieces and the pieces that have the little spinny parts on them and all those different kinds. And you can take those and put those together and build all sorts of different shapes and different objects out of them. Well, that's pretty much how the universe works, and these elements are sort of like the different types of Legos. And so using these different elements, we can put them together in different combinations and make everything that we see in the entire universe. So that's what the entire universe is made out of, but this is a really interesting set of pictures here. So basically the idea here is each one of these things that you see here is the periodic table, but what it's meant to represent is that the size of each of these little circles here represents how much of that element is in this case, the universe or the Earth or in you. And I think something really interesting to kind of take note of here is the similarities between these things. So you can see that there's a lot of this element, which is hydrogen, in the universe and in the Earth and in you that exists. You might know that water is H2O, and that H stands for hydrogen, and you might also know that the Earth has a lot of water on it and that you have a lot of water in you, and so that's kind of where that hydrogen is. But also, look, the universe has quite a bit of these guys here, and so does the Earth. And surprise, so do you. The universe also has a whole bunch of these guys over here. And so does the Earth. And so do you. And last but not least, universe, a bunch of that stuff there. Earth, a whole bunch of that stuff there, same stuff, and you have a whole bunch of that stuff there. Interestingly, all of this stuff in this area here are what we call metals. And so, yeah, a lot of you is made out of metal. So this is kind of an interesting fact. It's just one of those things to think about, that the universe and the Earth and you are more or less made out of the same stuff. And that shouldn't be too surprising. If there's a whole lot of that stuff in the universe, then it makes sense that a lot of things would be made out of that stuff. So these are the elements, and these are the relative abundance of those elements in the universe. And so you can see that the universe, the Earth, you are all kind of made out of more or less the same stuff. Yes, there are some differences. By the way, these little X's here basically means that there is either so little of it that it's hard to measure, or that we just don't really know how much of it is in the universe. So that's what those little X's are for. So over here, these things actually do exist in the universe. Obviously, they're there. We just don't really have enough information to say how much of that exists in the universe. And also some of these things, when you get near the end of this, are man-made things, so they don't exist naturally in the universe. But anyway, now let's take a look at this and look at how these things form in the earth. Well, remember that when the earth formed, it was basically a big ball of lava. And so just like when you drop something in water, the heavy stuff is going to sink towards the bottom. And really what we mean when we say the bottom or sinking down or moving down is we mean towards the center of the earth. That's what we mean by down. That's the direction that anything goes. When it's going down, it's going towards the center of the earth, whether you're over here or over here or over here. Down means towards the center of the earth, and up means away from the center of the earth. So heavy things fall down towards the center of the earth, and light things start to rise up towards the top, towards the outside part of the earth. And so heavy elements on the periodic table, heavy elements are the elements that are sort of towards the end section of the periodic table. This area down in here is where the heavy elements are. So you have things like iron sinking down to the center here. Iron is heavy. You have things like even gold and things like that sinking down to the center. And then you have some of the lighter elements from more near sort of the top up here, like things like carbon and oxygen and stuff like that, kind of floating up to the top of this area of the earth here. And of course, we have lots of oxygen in the uppermost layers of the earth, which is the atmosphere. That's the stuff that really floats up to the surface. And you may have noticed that we don't have a lot of things in the earth like helium and stuff like that. Helium is really, really light, and so it actually kind of tends to kind of float up into space. So the heavier elements sink to the bottom, lighter elements tend to rise up towards the surface, and so we tend to get a lot of the lighter elements in the crust of the earth. I'm sure you guys know about the layers of the earth and the crust. We'll go over that a little bit more later. But basically, the idea here is an interesting thing that comes out of that is the idea that a lot of what makes up the crust here is things like oxygen. Yeah, believe it or not, a lot of the rocks that you find, a lot of what they're made out of is oxygen, just like the atmosphere is made out of oxygen. So that's kind of how the earth formed and how things got what we would say segregated or kind of moved to different places and separated from each other. So heavy things towards the center of the earth and lighter elements towards the top of the earth. And then as these things move towards the crust of the earth and are moving away from this really, really hot area, all of that lava is going to start to cool down. And so that's when we're going to start to get all of these elements that are made out of individual atoms. This is an element. That's gold, and that's made out of just gold atoms. We start getting those forming molecules. They start coming together and forming groups of elements or groups of atoms to form molecules, and molecules are what combine together to form compounds. So this is one molecule of H2O or water, and this whole glass is filled with the compound that we would call water. So this is kind of like what early Earth looked like, and we see all of this lava up at the surface here, and we see some of it starting to cool down and harden and form the first rocks on Earth. And this is basically what the entire surface of the Earth looked like in the early days of its formation. Now, as these things start to come together and form these solid compounds, these molecules, some of those molecules come together in ways that form these really cool shapes. And what we call these are crystal structures. And what we mean by a crystal structure is that they just form a regular repeating pattern or shape. Some of them might be kind of a square or diamond shape. Some of them might be like hexagons or octagons or pentagons or things like that. And some of them might form these more complex shapes like these guys. But they all form these regular repeating patterns. And that's a key thing about this crystal formation. So what I want you to do is take a look at this little video clip here, and this is a clip of actually water freezing, and when water freezes, it does form these crystal shapes. Now, this isn't exactly the same thing as lava freezing and forming rocks, but it's basically the same process. And this is something you can see really clearly in this video clip.
Second, more dramatic experiment uses a supercooled bubble of soapy water. When a nucleus particle is introduced, the ice grows instantly. The ability of tiny nucleus particles to trigger ice growth is at the heart of the formation of snow.
All right, so that's a really cool little clip there, some super freezing of water, and you can see those crystals growing. And if you've ever really looked carefully at snowflakes, what you'll find is that they look like crystals like that. And in fact, every single snowflake ever, as long as it's not broken or something like that, but every single snowflake that has ever fallen, by the way, there are a few exceptions to this, to be honest, but pretty much every single snowflake that has ever fallen has 6 sides to it, and is sort of the same type of shape because the crystals that form when water freezes have 6 sides to them. So that's why that happens. So every snowflake ever, like I said, with a few exceptions, but every snowflake ever, as long as it's undamaged, has 6 sides to it. Pretty interesting thing. Even though they all look different, they all have 6 sides to them. So once these crystals start forming in this magma, once it starts to cool and harden, what you are going to have are these things called minerals. Minerals are basically the sort of building blocks of rocks. So once we go from minerals, those minerals can, lots of different minerals, and you can see there's all these different minerals, and we're going to learn all about these different minerals in class. But you can see that there's all these different minerals together, and sometimes they might get mixed together in the lava. So there's some lava that's made up of all these different types of minerals, and then the lava starts to cool and harden and forms all these different crystal shapes, and then that mixture of minerals forms rocks. And we're going to get into rocks, but I really want to stay on this idea of minerals first, sort of the building blocks of rocks. So basically, in order to be a mineral, you have to fit into a set of 5 very specific rules. So you have to be, first of all, naturally occurring, so not man-made. Secondly, you have to be inorganic. Now, let's start off by defining the word organic. Organic means something that is living or comes from a living thing. So, for example, an eggshell would be an organic material because it comes from a living thing. Plants are organic things. Coal is organic material because it comes from a living thing. It comes from the remains of fossils and things like that. So, inorganic means the opposite of that. It means not organic. So inorganic means non-living or not coming from a living thing. So these have to be things, like I said, that are kind of like rocks and stuff like that. So it has to be naturally occurring, not coming from a living thing, not a living thing. It has to be solid, not liquid. Remember, this is happening after the lava cools and hardens. It has to have that crystal structure that we were just talking about. And it has to have a unique chemical composition, to it. In other words, it's made of some certain element, and it is different from all the other elements. So it has a certain very specific set of elements. Remember how I showed you that the elements come together to form molecules. So it is a specific molecule that is made up of a specific set of elements. So how do we get minerals? We get minerals. Minerals form from cooling magma. First of all, that's what we've already talked about, the idea that magma or lava comes to the surface of the earth, it cools, it hardens, and so those crystals start to form, and you get something like this picture you see here. This is basically a rock that has formed from cooled magma, and so that could be a mineral right there, or a group of minerals that have cooled from lava. But there is another way to do this, and we'll try this out in class. This is kind of a cool experiment that we can do where we can actually grow some crystals. And so what can also happen is if you have a bunch of minerals dissolved in water, so kind of mixed into some water, you have all these minerals. If the water evaporates, what you have left is these mineral crystals that form. And a lot of times, we'll see in class that a lot of times these can form these big crystal structures in caves. You may have also seen something called a geode, which is kind of these crystals that grow inside of a rock. We'll talk about that, but that's basically how that happens. It's the minerals are dissolved in water, the water evaporates, and what's left behind is these crystal minerals. So there's our six-sided snowflake, right? 1, 2, 3, 4, 5, 6 sides. So a crystal is a solid in which the atoms are arranged in a repeating pattern, as I showed you before. So notice that these guys all have this sort of repeating, almost like a pyramid shape to them. That's what each molecule of H2O forms. Now, water can form a crystal structure when the atoms arrange themselves, when it freezes. So that's kind of an interesting example. That's sort of a, water is kind of a weird example of a mineral, but what's this? This looks kind of foreign. It almost looks like an alien world or something like that, zoomed in. But okay, let's zoom out a little bit. Does it look familiar yet? Still maybe not. Is it the Great Pyramids? I don't know. Let's see. Zooming out a little bit more. All right, starting to come into focus here. What is that? Well, that is salt. Salt is a good example of the idea of a mineral. Does it fit into all of our different categories here? Well, it's naturally occurring, definitely. It is inorganic. It doesn't come from a living thing. Yes, that's true. It is solid. It does have a crystal structure, and it also has a very specific chemical composition. In this case, to give you this example, in this case, salt is made out of sodium and chlorine. Those are two elements on the periodic table. So when they come together and form a molecule, we call that sodium chloride. That molecule is basically made of one sodium atom and one chlorine atom stuck together, and that's what salt is. An interesting fact is that sodium and chlorine are both by themselves are two very dangerous kind of things. Chlorine gas was used by the Nazis, mainly in World War I, to kill people. It's really nasty stuff. Don't worry though, the chlorine in your pool is already made safe. That's okay. But chlorine gas all by itself is really dangerous. Sodium is something that if you put it in water, it explodes. So these are two very dangerous things, but when we put them together as a molecule, they become something that's completely safe. Well, they might lead to make you kind of unhealthy if you eat too much of it, but basically it's safe. This is where salt comes from. So this is where we get our salt from, believe it or not. We get it from these big salt flats. And this is an example of that idea. You can see these pools of water here. So what they do is they allow that water to evaporate. And as I said, when water has these minerals dissolved in it and it evaporates, it can form these mineral crystals. And that's basically how we get salt. So take a look at this. What shape are those crystals? Well, they're kind of like a cube shape, right? So think about the idea of the different shapes of the crystals. Now, let's talk about how we can use minerals. Minerals are actually a pretty important thing in our life because we can use them for a lot of different things. First of all, a lot of gems are made from minerals. So things like diamonds and sapphires and rubies and stuff like that, those are all minerals, and those are rare, highly prized minerals. Why are they so expensive? Why are they so highly sought after? Well, one, because they're rare, they're kind of hard to find, and two, because they're pretty and sparkly, so people like them. And that's kind of the idea, but really basically they're no more than just sort of a rock, basically. They're just a pretty rock, so people. And you may know minerals as birthstones. If you know your birthstone, then that's a mineral. And so if you don't know your birthstone, here's a little chart for you. Go ahead and find what your birthstone is. I was born in October, so my birthstone is rose zircon, which is probably not the one I would choose, but I kind of like the peridot. That's kind of a nice one. Blue zircon is kind of a nice one too. I like the colors blue and green, so that's just me. Sapphires are kind of cool too. Ooh, emerald. I like that one. That one's nice. Anyway, but go ahead and check out which one is your birthstone. All right, our second use for minerals are things that are called ores. So these are useful minerals that can be mined for a profit. These are things like probably the one that you would be most familiar with here is copper. Think of all the things that we use copper for. Pretty much all of the electrical wiring in a building is made out of copper. And think about all the different wiring that has to go into everybody's house and all the other buildings, and plus all of those lines that you see going on the big telephone poles going down the street. All of that is made out of copper, so obviously that's an important thing for us for our energy infrastructure and all that kind of stuff. But all these other different types of minerals can be used for different things in our lives, and so we usually call those ores. Not the oars that you use to row your boat. This is a different kind of ore. So this would be an example of where we would get some of those ores from. This is an iron mine right here where we would dig up iron to use for different types of metal objects and things like that. Here you have a gold mine and a gold miner there. This is a diamond mine in Sierra Leone. This is where a lot of diamonds come from. And in fact, there's a bit of controversy around some of this stuff because some of these guys aren't really treated very well. A lot of times young children are put into slavery to do this, all so that the rich industrialized countries can get their pretty gemstones. So sometimes it might be, if you want to buy a pair of diamond earrings or something like that, it might be worthwhile for you to find out where they came from and find out if it was a safe and fair place where these workers get them from. This is probably more likely where you got your diamonds from if you have diamonds. This is a diamond mine in Siberia, and this is actually the largest hole that has ever been dug by human beings. So that's kind of an interesting thing. Biggest hole ever. All right, so we have two different main types of minerals. We have silicate minerals that contain silica and oxygen. Again, these are two different things from the periodic table, and that's basically what they're made out of. So this is one type of mineral, and we have non-silicate minerals. Those are all the other guys. So it's either a silicate mineral or it's not a silicate mineral. Silicate minerals are made from silica and oxygen. Non-silicate minerals are made from other stuff, other things from the periodic table. All right, now we need to figure out how we can identify these different minerals, and this is going to be really important. We're going to do some labs in class where I'm going to actually give you some minerals, and you're going to have to identify them based on their physical properties. Physical properties are basically things that you can observe. It's a characteristic that can be observed or measured without changing the identity of the substance. In other words, you don't have to do any sort of chemical reactions or anything like that. Those things are called chemical properties. So these are just things that you can look at, you can smell, you can taste, you can touch it, things like that. Okay, so those are physical properties. So let's take a look at these guys here and think about how we can identify what type of mineral these are. So what are some physical properties of these two substances? Well, one is gold and the other one is pyrite or fool's gold, but they look very similar, and that's why they call one of them fool's gold. We can see that they're both a similar color. I know they're not quite exactly the same, but that could have to do with the lighting of those two different pictures or something like that. They pretty much are both the same color. They look very similar to each other. So, how could we identify these? How could we tell the difference between real gold and fool's gold? How could we tell the difference? Well, here's an interesting picture for you. You may have seen the idea of people biting on a piece of gold to tell if it's real or not. Well, why do they do that? Well, the reason is because gold, real gold, is actually a very soft mineral. It's something that you can actually put a dent in it with your teeth. Fool's gold is not, and that's how they can tell the difference between real gold and fool's gold. So you could imagine that another property would be the hardness of that substance. That's a way that we can tell them apart. There's another way that you can do it too. You can take a little piece of tile and you can rub the mineral on there, and you can tell, and it will leave, sometimes some minerals will leave a mark on that tile, and the mark will be different colors. Well, for real gold, it leaves kind of a goldish color streak, but for fool's gold, it leaves kind of a black or dark green color streak. So that's another way that you can tell them apart and identify which one's which. So, what are all of the physical properties that we can use to identify minerals? Well, as we talked about, we have hardness, we have luster, which is how shiny they are, we have cleavage, which is kind of how they break apart, we have color, we have miscellaneous stuff like how they react with different things, we have streak, which is that color that they leave on a piece of tile, we have specific gravity, which is very similar to the idea of density. So, here are our mineral properties that you're going to need to know in order to be able to identify these different minerals in class. So make sure you know these. Luster, that's how light is reflected from a mineral. It's how shiny it is. So we have metallic luster, which is shiny, or non-metallic, which is dull. So A or B, which one is something with a metallic luster? Well, that would be A, right? Those guys are shiny. Which picture shows a metallic mineral with high luster, A or B? I would say B has more of a high luster. Our next one is hardness. This is how easily a mineral can be scratched, basically. That's how we figure it out, is by scratching the mineral and seeing how hard it is to scratch the mineral. And what we do is, at some point, we came up with sort of a list of minerals that go from hardest to softest. And the way that we figure this out is by who can scratch who. Our next one is color. Color tells us what atoms make up the mineral. We have streak, which is the one we talked about before. This is the color of the mineral when it is broken up and powdered. But what that means, usually the way that we do that is by rubbing it on some tile or something to get a little bit of the powder to rub off there so that we can see what color it is. We have cleavage and fracture. This is the way a mineral breaks. If it has smooth, flat breaks, we call that cleavage. We say it cleaves. And that would look something like this. Believe it or not, this thing was not, this picture of this mineral here, it was not cut into that shape. It basically, you could hit this with a hammer and what you would get is smaller shapes just like that. So that has to do with, as we talked about, the crystal structure of the mineral. Or we can have fracture, which means it has rough, jagged edges. This is basically would look like that. It looks like, I would say, more what you would expect a rock to break into if you hit it with a hammer, just some kind of random rough, jagged edges. But a lot of times, a lot of minerals have these crystal structures that actually makes them break into pieces that look like that have these flat edges to them. Here's some examples of some different types of cleavage. You can have a lot of different shapes that they will break into. Sometimes they will break off into thin, flat sheets like this muscovite here. Sometimes they will break off into different kind of rectangular shapes or stuff like that. So lots of different shapes that you can get that will help you to identify what type of mineral it is. Specific gravity. This is really how dense the mineral is. So remember density. Remember my favorite place in the world, the DMV. We've talked about density, mass, and volume. And remember, we measure mass on a triple beam balance. We can measure the volume of a mineral in a graduated cylinder using water displacement, and we can get the density from those two measurements. And that can tell us also what type of mineral. And last but not least, we have this miscellaneous category. So what do we mean by miscellaneous? Well, we have things like what it smells like. For example, sulfur. Sulfur smells like rotten eggs. That's a pretty good example of that. And we have solubility in acid. That means, does acid dissolve it? Will acid eat away from it? So those are all the things that you need to know about minerals. Remember, make sure you know this stuff. Make sure you come prepared to class because you're going to have to use this stuff in the labs. All right, so there you have it, the main things that you need to know about minerals. So remember, in order to be a mineral, you have to be naturally occurring, inorganic, that means not living, solid, you have to have that crystal structure, you have to have a unique chemical composition, like water is H2O, salt is sodium chloride. Minerals form from either cool. Minerals can also form by being dissolved in a liquid, and then that liquid evaporates and forms those crystals. And we have several mineral properties like luster, hardness, color, streak, cleavage, specific gravity, and miscellaneous things like smell and how it reacts with acids. As I said, make sure you know these things, make sure you're able to use these things. We're going to do them in class quite a bit, and I will see you then.